Okay. Now here is our second circuit in this lab. I have 3 resistors. They are connected in series. This is the schematic part. It's the R1 and the R2 connected in parallel. And here is how I connected. I try to make it clear as much as I can. When I started, we mentioned about this is the line, the red line and the blue line indicated that all those points in this row here, they are the same. And all the second one, the red, located in the red one, sorry, all those points here in the red, in the top one, they are the same point, and all the blue one, they are the same. So what I did, I selected the red one as the one common line, and I connected, for example, for here, 1 point for the, so this is the red line, connected entirely 1 point, and here is the blue line, I connected entirely in 1 point. So here is the represented my red color or red line, connected the R1, R2, and R3 at the same, in the top one, and the R1 and R2 and R3 in the blue one. So I connected 3 in parallel. And similarly, since they have the same, my power supply 10 volt is still applied at any point in the red positive sign, plus 10, and the lower side negative, which will be the negative terminal, this one. So here is the 10 volt apply for my my circuit. Now what we mentioned here in the class, when I have the parallel connections, I will use the current divisions. Basically the current through each resistance, it will be different, but the voltage through all the resistors, they will be the same. To confirm that, if I want to measure, set my digital multimeter to the volt DC, I measure the voltage across the R3, for example, here. Passive convention, here is the positive sign, and here is the negative sign in the lower part. I expected to see 10 volt in my circuit. I don't see it because I don't turn on my circuit. I don't have 10 volt yet. So now I have 10 volts, so this is my volt. We mentioned in the class, if you switch your connections, you end up with the negative sign. So let's try it right now. Imagine if I switch this one, I put the negative terminal in digital multimeter in the positive sign of the resistors R3, and the positive terminal go to the negative terminal of my R3. Sorry, this one is take it off. I know to do with the lab by yourself and recording at the same time is not easy. So let's just swap the connections, and here is the positive, here is the negative. So I switch it, and the only thing I will see, expect to see the same value with the negative side. Okay, so this is the first observation. The current or the voltage across all the resistors, they are the same. So if you switch, let me turn off the power. For the R3, for R2, I can use this connections. I should be see the same value. So this across the R2, power on, positive 10. So that confirm the voltage for the parallel connection the same. Now we're gonna find out what about the current divisions. Find the current I1 and the I2 and I3. Basically, theoretically, we have the R1 value, 1K. We have the voltage, Ohm's law. Directly, we can get the current through this branch. So we're gonna make it as a measurement. How to use it as a measurement? I connect multimeter in series. So what I do, I will take the terminal here, connect it to that. This one is the positive ammeters, and take it off from here. I connected my positive sign or negative sign of this the multimeter in this 2 point. Similar for this one, similar for this one. So for that one, I use this small piece of wires. The purple one has the one common one. If I want to measure the the current across the R1, I take out the second terminal for the R1. I connect it to the positive sign of the meters. If I want to measure the current through the R2, I take it off this part, I connect it to the positive, and all the negative connected to this piece of wire. And similarly for the R3. So now the negative terminal for my I3 current should be the same point. If I want to measure the current through the R1, I want to take off the second terminal of the R1. So now I need to connect the positive terminal for my digital multimeter to it. So connected here. Okay. So now we'll see what we have here. Change the scale to the amps instead of the current. Set the scale to the DC current and then energize the circuit. We turn on here. We end up 1 millimeters I1. So similarly for the I2, I have to turn off the circuit and get terminal of the I for the R2 in his place at any point. And now I2, I want to take the terminal for the I2 out, and I connect it with the positive terminal of multimeters and turn on my power, measure the current. Here is the 5 milliamps in that circuit. Okay, now the third one, similarly, turn off, get back the R2 terminal to the circuit and take the R3 terminal from the circuit and connect it to the positive terminal of the digital multimeters. Then turn on the power, measure the current 10 milliamps. So 10, 5, 1 milliamp as the voltage or the current I1 and the I2 and I3. So that's the way how we find out. The last part, if you want to find the equivalent RT, which basically this is done, we call it the RT. What I need to measure the current, we call it here is the IS. In this branch, I have VS. I can the Ohm's law to find that current. Okay, so let's do it measurementally. So in your BSpice part, when you click you run your simulations, you need to find out what's the value show to you the BSpice this value. You have here's the 10 volt and you can use it to find the RT. So here is the R total, basically equal VS or E in this case divided by IS. So now IS is different than the I1 and the I2. Let's get back the R2 or R3, sorry, to the circuit. So now I have 3 resistors, they are connected in series. Where I want to connect it, look at your circuit here. I can connect it here from the positive. This one positive terminal. I take it off and connect it to the second point from the positive sign. So that's the place I want to connect my ammeters. So I'll go to my circuit here. What I will do, I will take this one is off, connect it to the positive terminal of my digital multimeter. And now I want to connect it to the circuit at any point in this line here. You can use this one, you can use this one, either way. Or I can use the same point here that I take it off from it my multimeter. So now the 10 volt positive go to the positive terminal of my ammeters. Then from the meters go to the negative terminal of digital multimeter. Again, 10 volt positive go to the positive terminal of the ammeters. From the negative terminal go to my circuit and go through the circuit. That's exactly what we explained here. Take it off, put the positive terminal here, take this part out and connect the negative terminal in this point. Okay. Now make sure we have the ampere. Turn on. Read the current. Here is the 16 milliamps, which basically, if you remember, we found 1, 5, 10. If you add those three current, I1 and I2 and I3, you get 16, which is one is the Kirchhoff current law. Here is the IS comes in. Let's call it, here is the IS comes in. I1, I2, I3 get out. So IS equals summation of those three current. So that's confirm our value is here. So here is, in that situation, you have 16 milliamps. We have 10 volt in that case. You can find out your total resistors as the measurement. In your simulations, you read this current, you have the E, you can find the R. In your calculations, you can use the series or parallel connection equivalent resistance. That's the second or the third part in this lab. Thank you.